So we're going to look at dividing rational expressions today. It's not a lot different than multiplying, but we're going to quickly go through some review of dividing rational numbers or fractions before we get to rational expressions to familiarize you with some things. So the first thing you need to remember is that when you divide fractions, you are going to keep the first fraction the same, and you're going to do what's called invert and multiply the second fraction. You're going to change the division sign to multiplication, and then you're going to invert this. The numerator becomes the denominator, and so on. The second thing you do is you look and you see, can you simplify anything? So 2 goes into 14 7 times, and 2 goes into 10 5 times. So we now multiply. 7 times 7 gives us 49, and 5 times 3 gives us 15. Not too difficult. And we would do the same thing if we had 3 fractions. What we would do is we would change this multiplication sign, or sorry, division sign to a multiplication sign, and we would invert this second fraction. Now here, 5 goes into itself once, goes into 10 twice. 3 goes into 9 3 times, it goes into 6 twice, and 2 goes into itself once, and it goes into 20 10 times. So 1 times 2 times 1 is just 2, and 1 times 3 is 3, 3 times 10 is 30. Oh, I can still simplify this. So I know 2 divides into 30 15 times, so I get the answer of 1 over 15. So just like here with numbers, where once we thought we had the answer, we can simplify, you're going to do the same thing when we deal with variables. You're going to see that sometimes you think you have the final answer, but when you look at it, you can actually simplify and come up with something smaller or simpler. So now let's look at a couple of questions involving variables. So in this case, we are going to take and keep the first fraction the same, but we are going to invert the second fraction. And just like when we did multiplying, I'm going to try and use some colors when we do dividing. So the first thing we see is that 16 divides into itself once, it divides into 32 twice. Next thing we're going to see is that 3 divides into 9 3 times, divides into 15 5 times. We can then look at the variables. A divides into a squared, canceling one of these out, and b divides into b squared, canceling one of those out. So it looks like I have 3 times 2, which is 6, and I have an a and a b in the denominator, and 1 times 5 gives me 5. And if I look at this expression, there's nothing else I can do to simplify those things. And if we look at the next example, the first 2 fractions are going to remain the same, but the third fraction we're going to change to multiplication, and we're going to take its reciprocal. So negative 21 over z to the fourth, 10x squared y squared, 2z over 15x times negative 5xy cubed over 7xz cubed. Okay, so if we start looking at things, 5 goes into itself once, goes into 10 twice. 2 goes into itself once, and 2 goes into 2 once. Let's see what else. Oh, 7 goes into itself once and goes into 21 3 times. 3 goes into itself once and it goes into 15 5 times. So now I'm going to start canceling variables. The x in the numerator in the first fraction cancels out with the x in the denominator in the second case. If I look at the z's, z cubed cancels out with z to the fourth, leaving 1z in the numerator. Let's look at the y's. The y squared here cancels out two of those y's in y. What else do we have? I think that's about it. So in the numerator we have y, z, z, so that's y times z squared. And in the denominator we have a 5, we have an x cubed. So there we go. That's in simplest form. So lots of what we just did is very simple, similar to what we did when we did simplifying radicals, except we just have more radicals to deal with. Now, something we have to focus on next is how do we determine non-permissible values when we actually divide rational expressions. So if we consider this rational expression here, a over b has a non-permissible value of b, where b cannot equal 0. In this expression, c over d, the non-permissible value is d, where d cannot be equal to 0. But if you look at this expression, a over b divided by c over d, once I change it to a multiplication statement, you're going to notice that c ends up being in the denominator. So in this second fraction that we're going to be inverting, you have to look at the numerator and the denominator to come up with the non-permissible values. So in this case, c can also not be 0. So if we kind of summarize that in a statement, which is at the top of your next page, it says any variable which appears in the denominator at any stage of the simplification should be called a non-permissible value. So any of the variables that we're going to end up in the denominator have to be considered as non-permissible values. So what we're going to do here is, all we're going to look at is we're going to look at restrictions in this case. So if we look at both of these denominators, they have b's. So b cannot be equal 0. But if we also look at the numerator of this second fraction, that numerator is going to become the denominator in a second. So a can also not be 0. If we look at our denominators here to start with, we have x's and z's in the denominator. So x cannot equal 0 and z cannot equal 0. If we then look at the numerator of this third fraction, which is going to be inverted, it has a y in it. So also y cannot be 0 in terms of this. Okay, so we're going to take this and we're actually going to apply it to solving some questions. They want us to simplify some of these questions and they want us to state the restrictions. So the first thing I'm going to do is I'm going to look at the numerators and denominators and see if they need factoring. In this first example, none of these need factoring. They're already factored. So the second thing that I'm going to do is I'm going to state the restrictions. What can x not equal? Well, if I look at these first two denominators, x cannot equal 2 and x cannot equal -3. And this single x means x cannot equal 0. We've already used +3, so we don't have to include it again, but we need to look at this numerator of this second fraction. In this case, the x plus 1, when you solve it to 0, tells us we have a restriction where x cannot be -1. So we've done all of our restrictions. Second thing we're going to do is we're going to copy down that first rational expression, and then we are going to invert and multiply the second rational expression. So now we're going to start simplifying things. X plus 3 eliminates x plus 3. X plus 1 eliminates x plus 1. So if I look at what I'm left with x in the numerator, and I'm left with 2 times x minus 2 in the denominator with my restrictions that I've already stated. If you look at the second example, you're looking at this going, holy smokes, like this is a fraction divided by a fraction, like this is like really complicated. Well, it looks complicated, but really all you have to do to simplify this is you just have to rewrite this expression. It's 4x plus 12 divided by 3x plus 12 divided by 3x squared plus 9x over x plus 4 squared. So that looks exactly like this first question. We've just written it in a less complicated way. They're trying to kind of freak you out and scare you with this first expression, but don't get freaked out. It's just a fraction divided by a fraction, and we can rewrite it. So the next step before we do restrictions is we try to factor anything that we can. So in our first numerator, we can take out a common factor of 4. And in our first denominator, we can take out a common factor of 3. In this second case, I'm going to do my factoring and my inverting all at the same time. X plus 4 squared means x plus 4 times x plus 4. And I can take out a common factor of 3x, and I'm left with x plus 3 in my denominator. So now I can do my restrictions. X cannot equal -4, -3, 0, and I've got to consider what I put in my numerator here because it was in the denominator in the original expression, and it's -4, and we've already accounted for that. So there's my restrictions. So after I state my restrictions, then I begin simplifying. So I have an x plus 4 eliminating an x plus 4. I have an x plus 3 eliminating an x plus 3. So if I now multiply everything together in the numerator, I have 4 times x plus 4, and in the denominator, I have 3 times 3x, which is 9x. So there's our final solution with our restrictions. So that's not so bad. Okay, we're going to look at a couple more examples. Basically, only thing happening in these next group of examples is you just need to factor a little bit more and deal with some restrictions or some non-permissible values. They're not really that intimidating. Okay, if we look at this first expression here on the left side, we have to factor everything to start with. So remember, the first thing you always try to do when you're factoring is take out a common factor. And in our numerator on the left side, we can actually take out a 4x, and we're left with x minus 3. In our denominator, this is a difference of squares. So when we factor this, we get x plus 3 and x minus 3. Now, if I factor my numerator, I can take out 7x squared, leaving me with x plus 1. And in my denominator, if I use box method, two things that multiply to 3 and add to 4 are x plus 3 and x plus 1. Okay, so now I'm going to do my non-permissible values. What can x not equal? Well, x cannot equal positive and -3, and x cannot equal -1 if I look at my denominators. If I look at my numerator, okay, I've dealt with the -1, but I also have to include the 0 that's going to be dealt with that x squared. So plus 3 minus 3, -1 and 0 are my restrictions. So now I'm just going to rewrite what we have on the left side, and I'm going to invert the right side, and I'm going to start canceling things. X minus 3 cancels with x minus 3. X plus 3 cancels with x plus 3. X plus 1 cancels with x plus 1. And this x in the numerator takes out one of the x's in the x squared. So the only thing left in the numerator is 4, and in the denominator we have a 7x left. So there's our answer in simplest form. Now, in the next question, we're not going to solve this, but I do want to talk about it quickly. There are some brackets here. So basically what it means is we have to multiply what's in brackets first and get a solution, and then we have to divide it by the first fraction, which I think you can handle. Now, the last example we're going to look at is it's a combination of adding and subtracting and dividing. So I'm going to rewrite this expression. It's 10 over a minus 12 over 2a plus 1 divided by 5 over a plus 4. So the first thing we have to do in each one of these cases is we actually have to come up with common denominators, and we have to simplify those expressions first of all. So in our left-hand side here, we're going to have a times 2a plus 1 being our common denominator. So that means my numerator of 10 is going to have to get multiplied by 2a plus 1, and my numerator of 12 is going to have to get multiplied by a. I'm going to finish this. So our common denominator is going to be a times 2a plus 1. If I expand this, I get 20a plus 10 minus 12a. So if I simplify that, if I actually write that expression down, 20a minus 12a is 8a plus 10 over a times 2a plus 1. Now, I'm going to simplify the right-hand side. Our common denominator is going to be a. So when I simplify this, I'm actually going to get 5 plus 4a over a is what I'm going to get. Okay, so now I need to look at my two expressions. I've got 8a plus 10 over a times 2a plus 1. Now I need to multiply that by the reciprocal. And if I start looking at this, I go, oh, a can cancel out with a, and I think that's all I can do. But if I remember, I could have taken out a common denominator here of 2 in this numerator, and if I take out a 2, I get 4a plus 5. Well, that's the same as this denominator. So in my numerator, I'm left with 2. In my denominator, I'm left with 2a plus 1. And there we go. That is our denominator in simplest form and our numerator in simplest form. And that expression that looked pretty complicated when we started actually simplified out quite easily.